Hello, this is the second of two parts on exploring data with JMP, and in this section I'm going to introduce something called partition analysis in JMP. And this is actually the first time where we formally talk about the idea of cause and effect. In other words, I have some target or response that's important to me, and I'd like to study how some inputs to a physical system might influence that target. So this has a lot of implications for continuous improvement, where we're looking for causes or sources of variation in a response. And as you'll see later in the course, I'll go into this in more depth. But at this point, I wanted to just introduce the idea of partition analysis, modeling, and the idea of cause and effect. Up until now, we've just looked at a set of variables or features of some process that we're interested in, and we're just looking to see how they behave, look at their distributions, and possibly how they might relate to each other. So as I said, now we're going to build a model. And I'm going to use a nice simple file called auto raw data that's in JMP sample data, and the target or key response is whether or not a person holding an automobile insurance policy has filed a claim. And what we'd like to do is examine a number of characteristics of each policy holder to see if we can find something in those characteristics that would indicate the likelihood of their filing a claim. Essentially, you might consider this risk analysis. Okay. Getting very slow response time for my computer suddenly. There we go. So what I'm going to actually do is just go over to the JMP software and just walk you through the idea of partition analysis. Right now we'll view it as more or less exploratory. Later we'll view it in some depth as a really nice model building tool that can be used in many ways in Six Sigma to establish cause and effect relationships. Okay, so this is the auto raw data. I'm going to take this off of slideshow, it might get in the way. Here's our data in JMP. Okay. And ordinarily I would go through all the steps I've taught you about pre-processing, looking for missing values, outliers, and so forth. I'll just mention one column, claim. That's the amount of a claim in US dollars. The problem is it has a missing value for all cases where no claim was filed. So it's actually not very useful, because claim in dollars, as you're going to find out, is more or less confounded with whether or not someone filed a claim. So to do partitioning, you go to the Analyze menu, Modeling, and notice Partition is first. That indicates the people developing the JMP software considers this one of the key tools for someone to use, so they put it at the top of the menu. So we click on it. The target, okay, is whether or not somebody filed a claim. And then we have a number of potential factors. As I mentioned, I'm going to leave out claim because that's really confounded with a claim being filed, yes or no. And then I'm going to put in other factors. So I'm going to put in age. Okay. I'm going to leave out age class. That's actually also another one that's partially confounded with age. Put in gender, car power, rating class, branch. Some of these I don't entirely know what they are. And zone, region, and whether or not they reside in a city. Okay. So leave everything as is for the time being. In other words, there's some options we'll talk about later in the course. Click on it, and you get a display, and I'll give you some explanation of it. First, go under the main report menu, the red arrow, and under display options, pick show split probabilities. Okay, so what this tells me, I'll just show you quickly right here. I have 20,000 policy holders. 88% did not file a claim, 12% did. Okay, so we're not going to talk about the issue that there's only a small number of positives, but the question is, how do those other variables potentially help me predict whether or not a policyholder would actually file a claim? Well, I'm going to disclose this candidates list. And again, I won't go into a lot of detail, but notice we have all these potential things that could predict whether you'd file a claim. And you'll see this G-squared statistic, or something to the right called log worth. They're measures of how much variation in the response, which is whether or not you filed a claim, can be attributed to that variable. Okay. So I won't go into the mathematics of them, but the bigger that number, the more variation in the response they explain. In other words, age, as an example, has a large G-squared or log worth number. This means that age actually is a pretty good classifier as to whether or not you file a claim. What JUMP has done, it has gone through every potential variable, looked across its measurement scale, which could be continuous or it could just be sets of groups, and has found ways to separate that measurement scale that explains the most variation in the response. So here's what they discovered. That age, if they divide it up into groupings, what they've actually found, you're more likely to file a claim if you're 18 to 21 or you're 80 to 90. This is a brute force search. This is not something someone could do by hand. There's a lot of computational work going on under the hood, as we often say. So what we're going to do is click on split, and what split is going to do, it's going to find the variable that explains the most difference between yes and no, and it's going to show you how it split up the measurement scale for that variable. So I click on split. Okay. Notice on the left it says if you're 18 to 21 or 80 to 90, okay, if you look, 36% of those people filed a claim. If you're in the other age groups, 10% filed a claim. So this is, JUMP did this literally by brute force. It just looked through all combinations of age grouping and said this partitioning, and that's where the word comes from, of age groups gives us the best classification, or basically the best separation between yes and no. So it is very telling if you're in these, a young driver or an older driver, 36% of those people filed claims. Well, can we learn more? Well, let's try splitting again. Okay. Notice that once we split the first time, okay, there are other potential candidates. Okay. I'm not going to go through all the details, but JUMP once again at every stage goes through and looks for new ways to split. This, you're going to see in a moment, is the top of a tree. This is found to be the biggest classifier, the best classifier. So I'm going to split. Notice what JUMP did. It said, alright, on the right hand side, if you're in these age groups, here's the best separation between yes and no. So if you're in this age group, basically let's call it the middle age group, although that's a bit inclusive. And then let's take a look. If you live in a city, 15% filed a claim. If you don't live in a city, only 4%. So what JUMP is saying, alright, you're in this group on the right, and within that group we can now distinguish between people who file claims based on whether or not they are in the city. Let's split again and see what it did. This time it split on the left. So notice, even on the left hand side, whether or not you live in a city is an important contributor to why you file a claim. Notice this looks a bit like a tree structure, and it is. It's partitioning all of our variables into subgroups based on how well they can classify a policyholder as filing a claim or not. So to speed this up, I'm just going to go through and do a series of splits. I'll do about 8. By the way, 8 is usually in the partitioning problems, you've pretty well exhausted the ability to explain variation in the response. Later on in the course, I'll explain that you can oversplit these trees, and eventually you're just splitting on noise or nuances in the data and not really any capacity to explain whether or not a person files a claim. Well, JUMP has a few tools here that can help us, and one is a small tree view. So this is showing us how all the splitting occurred and where it occurred. Okay. And then something I find very useful, and it's called the column contributions report in the main report menu. This breaks down over all the splits that were done what explained the most variation, and the key is to the right. So whether or not you live in a city and your age group are the two key classifiers. Rating class, apparently that's some sort of risk class, I don't actually know, was the only other one that seemed to explain any variation. So things like gender, how much premium you paid, how powerful your car is, branch, zone, and region don't seem to explain much variation. So from an exploratory point of view, we've learned something. These are the 3 key characteristics of a policyholder as to whether or not they'll file a claim. Again, there's more we can get into. I don't want to do it right now. And finally, you can actually use this model to try to classify, say, a new applicant as to whether or not they might file a claim. And under the main report menu, and I'm not going to get into a lot of detail, you can do what is said, save prediction formula. Okay. So at this point, what I would typically do if I were building a model, I would go down under the main report menu to the script menu, and I'd save the script to the data table so I can reproduce this analysis at any point. Okay. But look what our model did. It went through every single one of the 20,000 entries, and using my little simple tree model, it just calculated the probability of filing a claim and said whether or not a person is likely to file one. Most are no, and we'd expect that since 88% did not file claims. But how well did we do? Well, we've learned about mosaic plots. How well did we classify? So let's go to fit y by x, and let's look at the variable whether or not you actually filed a claim versus what JUMP calls the most likely. All JUMP does is it looks at the 2 categories and picks the one with the highest probability and says, okay, that's your classification. It's a very simple rule. Okay. Well, how did we make out? Well, let me look at this table. So notice for those who did not file a claim, it got 98% of those correctly and about 2% incorrect. And for those who did file a claim, well, we didn't actually do very well. For yes, 86% were classified as no. So as a predictive model, it's not very useful. Again, we'll come back to this later on. But strictly from the viewpoint of exploratory analysis, we've actually learned a great deal. So partition, for this right now, I'm not going to worry about building a model to predict anything. I just wanted to explore the data and see what variables might be most useful as a classifier as to whether an applicant for automobile insurance is likely to file a claim.